Okay, welcome to grade 11 college math, and we're in unit 6, statistics, lesson 3, graphing data by hand. So we're going to graph and analyze statistical data in different techniques. So you'll take out your note and you can fill in as we go along. So we'll start with displaying data, like how to create graphs by hand. Once survey data is collected, it needs to be organized. It needs to be organized in a meaningful way so that it can be easily analyzed and interpreted. So by putting a visual, a lot of us are visual learners. I know who I am, and it really helps when I can see things in a graph, in a visual representation of data. So our first example is a bar graph. You, in your years at school, have done a lot of these before, and you've done these methods before. So in this way, it's quite a bit of a review. As always, it's hard to, what you need to always keep in mind is your scaling, which headings you're going to write, what variables you're talking about. Okay, so we're given, we're going to come up with a hypothetical situation here. And so I'm going to use some numbers that I'm sort of just grabbing out of the air here. But yeah, just go along with it, and we'll use these percentages. Suppose we would like to know what sport the favorite is amongst our classmates. Let's say we were to survey our class to determine the most popular sport. So since we're doing a video here, we have to come up with hypothetical numbers. So let's say that five individuals chose baseball. Now we're using a tally marker. Remember, we put a tick for each person counted. Remember, and for every 5, we do a cross tick. Okay, and that's how we see groupings. Helps us group quickly, visually. Okay, well, we're not going to do percentage until the end, until we know exactly how many students were in total surveyed. Now, the next one, let's just say the next one we had, again, make 5, and we'll make 6 students at basketball. Okay, for football, another 5. In hockey, well, we are in Stittsville, so let's make hockey one of the larger ones, and we'll say 11. Soccer, well, probably would be higher, but let's just pick some lower numbers here. And tennis, a little bit lower, obviously individual sports, maybe something other, like there's a equestrian rider out there or something. So when I gather these total, I have 34, which is 34 here. Okay, so we want to put these into percentages. So if 34 is our total, then we have 5 divided by 34, and then times on 100. So let's do that on our calculator. Again, talking about frequency, it's the count the number of ticks in the tally column and express it as a number. Percentage is your calculation divided by the total times 100. So 5 divided by 34 is 0.14 times 100. Well, it's 0.147, so it's 14.7%. So we can carry a decimal here. Okay, let's. We don't have to write this out each time, but we have 6 divided by 34. We'll do it a couple times so that you know to follow the pattern. Okay, so that's going to be 0.176. So times by 100, we have 17.6. Okay, and so we continue. So 5, we're going to get the same number here, 5. So we're going to get 14.7. We'll repeat that. And here's our big number. So 11, going on our calculator, 11 divided by 34 is almost a third. So we have 32.4%. Okay, now we get smaller numbers here. 4 divided by 34 is going to be 11.8%. 2 divided by 34 is 5 times 100 is 5.9%. Okay, and one final one there. 1 divided by 34 is going to be 2.9%. So those all do add up to 100%. And that should be the case. All right, so we have broken this down now. Now, that's a bar graph. So, or no, that's a data table, and we're going to convert it to a bar graph. Now, the nice thing is we already have a grid to use. Create a bar graph. Remember to fully label your graph. Okay, so on here, you would want to have the frequency. Now, I'm writing vertically, but probably could turn my pen sideways and write it out properly. And then we have the sport along the bottom. And so I think I'll give myself a little bit more space here. Oh, it won't let me erase that. What's going on? Okay. Yeah. Okay, so let's continue. Okay, so sport along the bottom. And let's just do each one here. So in our first area, we'll use baseball. And then basketball. You don't have to worry. Just follow what's in the data table. Football and hockey and soccer. Oh. And tennis and other. Okay, so again, you can get creative with colors and all that, but basically we're going to shade this in. We're going to make a bar graph. So the numbers on the left side indicate the frequency, and label the bottom as the bar graph to have the category of the sport. So for basketball, we had 5, so that's going to fit right in between here. And you can sort of shade this in. Okay, then, so that was baseball. Basketball is 6, so it's right here. Okay, football went to 5. So we're making bars. That's why it's called a bar graph, these vertical bars that go up. We went up to 11 for hockey. again, you want to take your time, do these right. I'm probably rushing a little bit more, and if I was doing this as an assignment or to hand in, or I'd probably take a little more time to do it properly and fill in everything nicely. Okay, soccer was 4. Tennis was, what was tennis? Tennis was 2. Mm-hmm. And other was 1. It's worth noting that there's something a little bit odd with this grid that we were provided with. But so here, there's a little bit of a gap. So that's probably an error. We don't want to make that error. So really the 0 should have been down here. Okay, and one last thing is it did say to label fully, and we don't have a title. So here, so we'll say the favorite sport survey, let's say. Come up with a good title. Okay, now, what else do we want to point out? Categorical data is data that are types rather than numbers. For example, sports, baseball, basketball. So we talked about this in the very start of this unit, that we could have categorical analysis, we could have discrete, and we could have continuous. This is categorical. There is no in-betweens. It's not like you could, well, at least in this survey, it wasn't like you could half like baseball and half like basketball. So it's not, there's no continuous data here. And yeah, and it's not discrete because we're talking about different factors here. It's not like we're talking about the amount of rainfall in 1 month, and it's all rainfall. These are clearly different categories that we're measuring or tabulating. Okay, write a statement about your findings. So what could we say? So for just glancing quickly at this graph, we can clearly, what stands out is hockey being quite a bit ahead of others. So even from the table above and the graph here, we could come up with a conclusion that says, hockey is the most popular sport among classmates. 32.4%, we got that from the table, prefer hockey over other sports, let's say. Okay, so that's our first look at a bar graph using a data table to help. So bar graphs are very useful. The next one is a histogram. Histogram is like a bar graph. It just takes on a bit of a different look. So what happens here is we still start off with the data table, which is up here, and then our histogram will do on the grid graph. So let's read our situation here. Tina would like to know the average number of hours her classmates spend watching TV during the week, Monday to Friday. Okay, so here are our range. So we have ranges 1 to 5 hours, or 0 to 5 hours, 6 to 10 hours, 11 to 15 hours, 16 to 20, 21 to 25, 26 to 20. So these are, again, categories for watching TV. And we were given the information already, so we have 3, 4, looks like 8, 5, 3, 2. Okay, so let's just write those in. So our frequency again was taking that tally number and putting it into a value. Okay, 3, 4, 8, 5, 3, 2, and that does add up to 25. Now, it doesn't say it here, but let's look back. We called that the percentage. So let's build ourselves a third column that it should be here to begin with. But so we have a total of 25. So we are doing 3 divided by 25 equals 12% or 0.12. So 12%. Okay, we're going to do 4 divided by 25. We have 16%. Okay, 8 divided by 25. We have 32%. That's our biggest number. Okay, back to 5 divided by 25. Well, that's 20%. We have another 3, so we already knew that, 12%. And what's 2? 2 divided by 25 is 8%. All adding up to 100%. All right. So what can we do with these numbers? Well, we can create a histogram. All right, so we have a title again, hours watching TV. We have the frequency along the side here. We have the number of hours in certain intervals. So again, it's not continuous data, it's categorical. All right, and maybe I should give myself some more room here. Let's just see what I can do to group this and move it down. Okay, so let's turn again to the side. And in a histogram, you want your largest to be, we want to go in order again. So you're going in between the gaps here. So 0, just need my pen. 0, okay, 1 second. It's too thick. Nice thin pen marker. So 0 to 5 hours, 6 to 10, 11 to 15, 16 to 20, 21 to 25, and 26 to 30. Okay, so now usually with the histogram, we might pick different colors. So maybe what I'll do is I'll do that with this. Okay, so for 0 to 5, if we look at the table above, we had 3 respondents. Okay, it's for 6 to 10, we had 4. And so the first thing you notice about a histogram is that the bars, so it's like a bar graph, but the bars are stacked right beside each other. Okay, for 11 to 15, we had 8. That was our biggest number. And for 16 to 20, we have back again to 4. Picking different colors for each of these. And 21 to 25 was 3. Oh, I need a different color, I think, eh? Maybe we'll use some purple here. And 26 to 30 was 2. All right, we got a nice little rainbow here of colors. So that's good. All right, so there's a histogram using perhaps different colors or maybe different shading, whatever you could do. Maybe with a printer you might be limited with doing shades of gray. All right, so write a statement about your findings. Well, what do we notice? On average, or the most popular is our students that are watching about 8 hours of TV. No, sorry, 11 to 15 hours. So most people in Tina's class, going right back to the start of the question, the situation. Okay, watch 11 to 15 hours of TV per week. Now again, this note is older, so it's possible that people are not watching TV as much, but streaming, right? That's a whole new thing. Sometimes these notes are like 10 years old. So what's changed in our lives is we stream things on our devices. So anyways, but we could easily change this, and make it how many people are online or on their devices that many hours a week. Okay, so what's the difference between a bar graph and a histogram? Let's make a few points here. The types of data. So a bar graph we are looking for categories. Okay, an example could be donuts, or plain, frosted, filled. All right, whereas a histogram is more for continuous data. So in the bar graph at first, they're clearly distinct things. Like we did the sports, so it was basketball, baseball, football, hockey. Here, we're talking about donuts, plain, frosted. There's no continuous information. These are clearly plain, different categories. Whereas where we're watching the TV, at least we're talking about hours of watching TV. So there's only one variable there, hours of watching TV. So it is, in a way, it is categorized, but it is continuous data. And that's the key difference here. For categories, for continuous data. So usually this is in numerical situations. Numerical data expressed as intervals. For example, so instead of intervals, instead of categories, we have intervals of continuous data. So 0 to 5, 6 to 10, etc. All right, now that's the types of data that we would look at. Now number 2 factor is talking about how the graphs are drawn. Well, the bar graph pardon me. Well, we have space between. So we had, examples like where there's space in between the categories. And that's, again, showing that these are distinct categories. They're not connected to each other. So that's where the idea of the space between, that they are separate categories. So, and then when we talk about histogram, the fact that they're sort of drawn right next to each other, it kind of shows that we're talking about the same type of information, like hours of watching TV. Hours, it's still hours compared to hours, and so they're not as distinct. All right, so there's no space between the bars. So we would have different bars, different heights, all in comparison. Right, such as that. Good. So we did talk about categorical data the previous slide, and so here's a good reminder of what continuous data is: data that can hold any numerical value. So we're holding a numerical value for hours of watching TV in this case. Okay, finally, so we've done a bar graph, a histogram, and now everyone's favorite. They're difficult to draw, but they are very effective when we look at information. I find circle graphs are very good, or we call it a pie chart. So here we have a situation. So doing this pie chart, we're going to have some information. Sean is curious to know the number of people his classmates had in their family. The following shows what Sean recorded for his notebook. For example, one person responded, the number of people was 2. So the number of people that had two people in the family, there was 3 that had that. 3 students had a family of 2. So, right, there's one parent, one child, for example. Here, maybe we have one parent, 2 children, or 2 parents, 1 child, and so far and so forth. Now, it doesn't get into those different combinations, but it's just in total. So here we go. So let's continue. So we have a good model here of what to follow when we talk about the percentage and the measure of the angle in degrees. This is interesting because we're going to want to use the amount of curvature or angle of the circle pi size. So let's do this. All right, so we have 4 here. We have 10. We have 4. We have 2. No one with 7 people, and one family had 8. Okay, so we have 4 out of 24 times 100. Well, what does that get us? 4 divided by 24 is 1666666, so times 100 is going to give us 16.7%. All right, what do we do on this side though? So we say, all right, I'm going to need 360 times this number. So 4 over 24 times 360 gives us how many degrees we can use for making our pie slices. So 4 divided by 24 times 360 equals 60 degrees. All right, let's keep going. So 10 divided by 24 times 100 is, well, 10 divided by 24 equals times 100. I have 41.7. 10 over 24 times 360. Okay, so I have 10 divided by 24 times 360 gives me 150 degrees. Makes sense. This is the largest degree so far because there's so many, there's lots with a family of 4. Okay, so here we go again, 4 over 24. Again, that actually repeats up here, so we know it's going to be 16.4. We know this is going to be 60 because it's 4 and 4, right? You get that? All right, and now we go to 2. 2 divided by 24 times 100. Okay, so 2 divided by 24 times 100 is 8.3%. All right, 2 divided by 24 times 360. 2 divided by 24 times 360 is 30. Well, it makes sense. It's half of the 4. Okay. 0, well, that's going to be 0 degrees and 0%. And then 1. Okay, well, 1 divided by 24 times 100 is 1 divided by 24 times 100 is 4.2%. Okay. And one last one here. 1 divided by 24 times 360 is 1 divided by 24 equals times 360 is 15 degrees. Okay, so this adds up to 24. This should add up to 100. This should add up to 360. How are we going to turn this into our, now a protractor would be good to use. I don't have one, so I'm just going to make basically an estimate. Okay, so the way you calculate your percent, we talked about up there. So frequency divided by total times 100. Degrees would be frequency divided by total times 360. In order to label or color the different portions of the circle, a compass or a protractor must be used, right? We really should use that. I don't have one readily available. I don't think there's one in tools. Yeah, there's no like overlay for protractor, unfortunately. So we're going to have to sort of go along with it, okay? All right. So normally what you want to do is make your largest portion, to the, well, it doesn't really matter. Like what I might want to do is start at the top here, make my largest section, but that's a little difficult now that they put this line here. Well, let's try. We can do, our largest portion is the 42%. of people. So 150. So 150 is, well, let's say if this was 180 to come across here, okay, 150 would be, maybe somewhere along here. And maybe I can get a line here. Let's get a line. Okay. So there's going to be our 10 is going to give us our 42. So, okay, so now we have 10 people. Oh, which is the 42%. What's our next greatest category? We have, so we've done the 42%. So next we have a 12. We have 16 and 16. So let's do these two next. The 4 and 4. So those are both 60 degrees and 60 degrees. So for 3 people, well, 60 degrees would be, well, 90 degrees is like this. So 60 degrees would be somewhere in the middle there. If that's 90 degrees, that's 60, that's 30. So let's go right here. Let's get another 60 degrees because we had the two groups. We had the 4 and the 4. Let's go with another 60-degree pie chart. Again, good if we had a protractor. Now let's fill those in before we forget what we did. So this is 4 people. Oh, right. Yes, I see what we've done now. Okay, so again, it's 3 people in a family, 5 people in a family. So I named this wrong. The biggest group is 4 people in a family. We're also supposed to use different colors, so let's try that. So let's just choose a different color. So let's do 5 people. Okay. And so this was 60 degrees, right? Or no, percentage-wise, this is 16, so 17%, 17%, 42% we have there. All right, let's keep going. So now it's getting narrower and narrower. Our next biggest group is where there's 2 people in a family. 2 people in a family. So, okay, so let's choose a different color. Now, 2 people in a family, we're looking at 45 degrees. So if we were to sort of think about being at 90 degrees here, halfway to that is right here. And I should have did that in black. All right, let's try that again. There we go. All right, and we'll go back to that purple color. And so we have 2 people. So 1 parent, 1 child. And the frequency of that is 3 people. 3 tally markers, but end up being 12.5%. 12.5. We'll just round that to 13. Okay, so then we're left with, again, let's just make sure we've gotten everything here. 42%, we got our 16%, 16%, we got our 13%. Now we're down to this 8% group and this 4% group. So 30 degrees is not very large for a line, and our last one is 15. So between the two, it's 45, and that's roughly where we're going there. And so let's make that pretty small for the 15. Okay, and we're going to need a smaller marker and maybe a different color. Okay, so let's do that. So we have 8%, and that would be a family of 6 people. Okay, and then we have the smallest group is 4%, and that was a family of 8 people. And the family of 7 doesn't register, so we don't have that. Okay, so there you go. Now, you could shade these in with different colors, so on and so forth. So, can we write a statement? Sure. What would we say? Well, most people in Sean's class all right, 42%, so that's most of the people, have 4 people in their family. Very good. Now this is discrete data, so you can't have half a family member. You can't have 3.5 people in a family. You can have 5.5. You don't count the dog in your family members in this case. So in that case, it's discrete. All right, so data that is distinct and that can be counted. So very good. That's our lesson. Yeah. Okay. Thank you very much for watching this lesson, and we'll see you next time.